Hello. So here I'm going to explain how you prove the sum of an arithmetic series. This is something that you are expected to learn, and it could come up as one of the proof questions. So I'll just take you through it step by step. So the first thing, if we want to take the sum of n amount of terms, we would have the first term, a. Okay, so we know that that's where we start. Then we want to have the second term, which we would write as a plus d. That's the second term, so one difference added. Then we'd have the third term, which is the starting term with the two differences added. And if we continued with that, we would get to the first term plus n minus two differences, and the final term, which would be a plus n minus 1 differences. And there we would have it. Okay, so remembering that the final term would be n minus 1 differences, because we're only getting as far as n. Okay, and the first term, a, counts as that first one. The second line, okay, I'm going to write that in reverse. So I'm going to start off with a plus n minus 1 differences, okay, and then the second to last term would be n minus 2 differences, and keep going. We'd have a plus the 2 differences, a plus 1 difference, and finally a. Now let's say I was then going to take those two lines and add them together. I would have the sum of the series twice, so 2 lots of the sum of n. And then if I collected all of my terms, notice how here I've got an a and an a, so I would have a twice, and then putting the rest of them together, I would have n minus 1 times the difference, and I'd have that n times. Rearranging that then would give me Sn. So if I divide both sides by 2, I'd then get n minus 2, 2a plus n minus 1d. Okay, so that would be the series, the proof. That's all you'd need to do for the proof of the arithmetic series. Okay, so the second proof that you need to do is to prove the geometric series. So we're going to start with the same. Let's say we want the sum of n terms. Our first term would be a. Our second term would be a multiplied by the common difference. Our third term would be a multiplied by the common difference twice, so squared. Our next term would be a times by the common difference to the power of 3, because we've timesed it 3 times now to get from the first term to that fourth term. And if I keep going, then when we get towards the end, it would be a to r to the power of n minus 2, and the final term would be a times by r to the power of n minus 1. Remembering again, same as the last one, we're not going to get as far as n because a counts as the first term. So if I'm wanting to get to the nth term, I'll still have n minus 1. Now for this proof, what we do on the next line is we're going to multiply through every term by r. So the sum of the series multiplied by r, I'm going to just slightly arrange where I put this. So the first term a that I had here would now get multiplied by r. The second term here would get multiplied by r, giving me r squared. You can see why I'm lining these up. I'd have r cubed plus a r n to the minus 2 plus a r n to the minus 1, but I'd have also at the end a r to the power of n. Now what I do with these two lines is subtract them. So I'm going to subtract one from the other. So on this side, on the left hand side, I'd have the sum of the series subtract r times the sum of the series, and we can see here these will cancel, as will these. These will cancel, these will cancel, these will cancel. So what I'll be left with is a minus a r to the power of n. Now, to keep it nice and tidy, what I'm going to do here on this side is take out a factor of a, so 1 minus r to the power of n. And then on the left hand side I'm going to take out a factor of the sum of n, so 1 minus r. So rearranging that now to make Sn the subject gives me the formula that we have used in lesson. So a brackets 1 minus r to the power of n all over 1 minus r. And that's it. So I would suggest that you copy both of those examples in and just make sure that you're able to reproduce those should be required to in an assessment. Thanks for listening.